Hello. So today we're going to be looking at angles of a circle. And I say angles of a circle because we have different angles that are a part of circles or that are formed around circles. So the first one is known as a central angle. It's an angle formed at the center of a circle. The second one actually has, there's two cases, so really three types, but there's two cases for the second one. The second one's called an inscribed angle. So inscribed means that you're inside of something. So in this case, an inscribed angle of a circle is inside of the circle. But isn't a central angle inside of a circle? Yes, and actually you could define a central angle as an inscribed angle. So really we're just looking at two different types. The last one would be an angle that's outside of a circle, or an exterior angle of a circle. Different from an exterior angle of a polygon that we talked about before. But we're going to be looking at these and how to find these measurements of these angles. And it's going to be based off the measure of the arcs. So that's why it's important to understand the measurements of an arc and what an arc is in order to find these. So first and foremost, let's start with a central angle. So we've already looked at this before, but let's look at it again. So a central angle So this is a central angle. It's an angle whose vertex is on the center of the circle, or is formed by the center of the circle. So yeah, that's a central angle. The cool thing about a central angle is that the measure of the arc is the exact same. So if this is theta, that's theta. If this is 45, that's 45. If this is 90, that's 90. If this is 127, this is 127. No matter what this is, no matter what the measure of the arc is, it's the same as the central angle. No matter the central angle, it's the same as the measure of its arc. And we call that arc an intercepted arc. Intercepted arc, as if you were to extend these out, these radiuses are grabbing onto it like an interception in football. Okay, so that's an intercepted arc. So a central angle has the same measure as its intercepted arc. Okay, and an intercepted arc has the same measure as its central angle. So that's the first thing. So as I said before, we've done problems with this. If this is 20, this is 20. If you find out this is 40, well, guess what? That's also 40. So it's super simple. And this concept is going to be carried on to the others, actually. All right. So let's look at the second one, or what a central angle really is, honestly, is an inscribed angle. So an inscribed angle is an angle inside of the circle. So I'm going to show it to you looking at a central angle to kind of help define what it is. Okay, so an inscribed angle is an angle inside the circle. So how is an angle actually formed? Well, if you remember, it's where two line segments intersect at is where your angles form. But in order to actually have two line segments, if we really think about it, it's two lines intersecting. So like this is how we get our angles. This is how you form all angles. You have two lines intersecting. So really, at some point, this was a line. So this was an extension here, and there was an extension here. Okay? Well, we know from vertical angles that if this is theta, this is also theta. Okay? And I'll just call this some other thing. I'll call it alpha. That makes this alpha here. Well, because these are central angles, this is alpha, and this is alpha, and that's theta because that's theta, right? That's we understand that from the central angles. Okay. What about if this intersection was not at the center? What if it was in a different place? Well, how would I be able to find these measurements? Okay. Well, let's take a look. Based off the fact that we do know these. So if since this is at the center, we know that if we were to add these two things together and then divide by 2, that's what this would be, right? It would be the average of these two arcs. Same thing here. This angle would be the average of these two arcs. Because in order to form that angle, you need both of these arcs. It intercepts both of these arcs. These lines that are used to form this angle here, they intercept both arcs here. And so it's kind of an average measurement between these two arcs. Okay, So it's a little easier to see when we're looking at it from a center angle, because if I take theta plus theta, I get 2 theta. 2 theta divided by 2 is just theta. And so each of these is theta. Same thing with alpha. Let's look at it with some numbers there, and let's not put it at the center of the circle. So we're going to do an inscribed angle that's not at the center of the circle. Okay, so I'm going to say that so let's say that this arc is 165 degrees. And let's say that this arc here is going to be 35 degrees, okay? And I want to find out what is this angle here. So this is 165 degrees and this is 35 degrees. I want to find out the measure of this angle here, okay? All right, so because I know that this angle is formed by the intersection of these two arcs, if I were to try to form this or move this angle to the center, what would happen is that this angle would have to be the average between these two arcs. So that means that theta would equal 165 plus 35 divided by 2. So 165 plus 35, we get 200 divided by 2. So theta is 100 degrees. And that makes this guy 100 degrees. Okay. Could you actually find the other angles as well now? Yes, you can. Well, how could you do that? Well, we know that because this is a line, the angle on a line, is a straight angle, meaning these two angles are linear pairs. So this is 100, this has to be 80 because they have to add up to be 180 degrees. And if this is 80, this is also 80. And you could use that information to find out what are these arcs. So let's say, for example, if we knew then that, let's see, I don't want to do the same thing here. I want to do it greater. So let's do that. This is, so this is 90 degrees here. So if this is 90 degrees, what does this guy have to be? So let's call this x. Okay, so we're kind of doing some other problems you could do with an inscribed angle. So because we knew that this was 165 and this was 35, we took the average of those and we got 100 as the measure of the angle inscribed in the circle by those intersected arcs. And because of that, we then find out that, hey, because this is a line, these angles form a linear pair, meaning that they're supplementary, meaning they sum to 180 degrees. So if this is 100, this has to be 80, which means this also has to be 80. Well, let's say that this arc is now 90. We're going to find the other arc. So how are we going to do that? Well, remember that the angle, 80 degrees, will be equal to the average of these two arcs. So the 80 degrees will be equal to the 90 plus x divided by 2. Well, how would you solve for x? Of course, you would multiply both sides by 2. And so we would end up getting that 160 equals 90 plus x. And then how would you find x now? That's right, you would subtract 90 from both sides. And we end up with that, hey, x is equal to 70 degrees. So we found out that because we knew these two arcs and this arc, we were able to find out that this is 70 degrees. Because we knew that this angle was 80 and this was 90, the measure of this arc was 90, this had to be 70 degrees because this angle has to be the average between the two. And this would make sense. This is supposed to be 360 degrees around the circle. So it's 165 plus 90 plus 35 plus 70 is 360 degrees. So everything comes together still. So this is an inscribed angle, an angle inside the circle. We began seeing this from looking at a central angle, right? Well, there's another way you can have an inscribed angle, an angle that's still inside the circle. So let's take a look at that. So this one is called an inscribed angle. An inscribed angle. Okay, so an inscribed angle is an angle inside the circle. So it's not anything new. We just saw 3 different versions of that, right? This time, though, it's on the circle. Well, where's the angle? The angle is still inside. It's just the vertex is on the circle. So to find the angle, it was just, see, this is the arc is x. To find the angle was half of the intercept of the arc, right? It was the average between the two. Well, what's the other intercept of the arc over here? It's 0, right? Because they're meet there on the circle, so there's nothing else on the other side. So that measure of the arc on the other side is 0, and this one's x. We still need to take the average of the two. So that means that this would be x plus 0 divided by 2. And so we just get half of whatever the arc is. It's no different from what we did before. It's just half of whatever this arc is. So in x's, this is just 1/2 of x. So whatever the arc is, if it's on the circle, you just take half of the arc. Or if you know the angle, you just double it and you get the measure of the arc. Let's look at an example. So let's say that this arc is, let's say this arc is 90 degrees. Okay, so this arc is not measures 90 degrees. Well, to find the measure of this angle that's on the circle, this inscribed angle, I would take that, let's call this theta. I would say theta is equal to 90 plus 0 divided by 2. Because 0 would be the other arc over here because there is no other arc measurement. And we still need to take the average of the 2 arcs though. So in this case, we get 90 divided by 2, so we end up with 45 degrees. So that would be 45 degrees. Okay, cool. Well, that's simple enough, right? Okay, let's look at a different example. This time I want to know what the measure of this arc is here. And I want to know, I know that the angle measurement is, let's just say the angle is 65 degrees. Okay. Based off of the rule for inscribed angles, what I know is that, hey, 65 degrees has to be equal to x plus 0 divided by 2. Well, how would I find out what that is? How would I solve for x? That's right, I multiply both sides by 2. And so I end up with 130 degrees is x. So this is 130 degrees. All right, cool. Well, it can get even more powerful if you say you knew the radius, if they gave you the radius or the diameter of this circle. Even though it's not drawn, they could give it to you. And they could give you the arc length. And from the arc length, you could then find out, hey, what's the central angle supposed to be for this guy? And then therefore know what the measure of this angle is, and then solve for the inscribed angle. Or go the other way. You can find the arc length if you know what this angle is to get this, to find out what the central angle should be for it, and then use that to solve for the arc length. So it becomes even more powerful. So that's all the ways you can do it for inside of a circle. We have our central angle. We have it when it's not a central angle but still inside, and when it's directly on the circle. So there's only one other type of angle we're going to look at, and that's when it's an exterior angle, or an angle that's outside a circle. Exterior in this case just means it's outside a circle. It's not how we did with the polygons. Although some have argued that it's the same, and I can totally see why, but you don't need to know about that or worry about that at this moment. It's kind of cool to look at. So if you do want to know about it, let me know. All right, so this is how we're going to look for an exterior angle. And so an exterior angle is an angle that's formed outside of a circle. Okay, so there's a couple of ways to do that. You can have secant lines, right? We can have two tangent lines. We could have a secant and a tangent line as well. But for now, let's just look at the first one. Let's look at a secant. They're all actually the same. It comes with the same thing. If I want to know what is this measure of this angle here, theta, I need to know two things. I need to know what is the measure of this arc and this one. Well, why? Because once again, it intercepts two arcs. It's intercepting two arcs every time, correct? Okay. And you could even argue then that if you want to, that the measure of this angle, or the measure of an angle on a circle, can be found using this method as well. A lot of people still think of angles on a circle as inscribed angles, so that's why I taught it that way. But anyway, angle outside the circle. Let's see, how do we find it? Well, this arc here, the larger arc is x, the smaller arc is y. What does that have to do with that? Well, before we took the average of them, we added them together and divided by 2. This time, though, to find the angle, we're going to subtract the larger arc minus the smaller arc and divide by 2. Well, why is that? Because for this to continue to extend, it's gaining more arc. And so to find the true average between these, if this angle were inside, we'd have to subtract these two numbers. So it's kind of like averaging the distance between them, okay? Or finding the midpoint between them. Or midpoint still be average, but yes. All right, so let's do that then. So this is what we would do. We would take, to find the angle outside the circle, we take the two intercepted arcs, subtract them, and divide by 2. Okay, well, let's look at an example. So let's say the measure of this arc here is 20 degrees. Let's say this is 100 degrees. Let's find out what the angle would be. So we would take the measure of our larger arc, 100, minus 20, and we would divide by 2. Okay, so in this case, we get 80 divided by 2. And so we would get 40 degrees. So the measure of this angle would be 40 degrees. Okay, that's simple enough. Well, let's say instead we were told that, hey, this angle is actually 30 degrees. And we need to find out what's the larger angle here, or larger arc here. So we know that 30 degrees is equal to x minus 20 degrees divided by 2. Well, how would you solve for x? That's right. We would take 2 times 30, and we would get 60 equals x minus 20. And then you would add 20 on both sides. And so the larger arc would be 80 degrees. Okay. You can do the same algebra manipulation if you were given the larger arc but not given the smaller arc, and you're given the angle. Right? And so that's how you find the measure of an angle outside of a circle. What do you notice is in common with all these? It's always taken half. So for the inscribed angles, whether it's formed at the center, whether it's just somewhere else inside the circle, or if it's directly on the circle, or whether your angle is formed outside the circle, you've always taken half of some operation between the intercepted arcs. When it was inside, you were adding them. When it's outside, you're subtracting them. Okay? All right. So that's how you find measurements of angles. And again, you can use these angles then to go back to find out, hey, what should the central angle be for this arc? And then once you do that, you can find the arc length, or go for arc length backwards. All of the parts of a circle, they intertwine with one another, and they help define one another. So if you know all the properties and understand them, you'll be able to find all types of measurements for a circle. So that's how we find the angle measurements within a circle, and I will see you soon.